Hello everyone, welcome back to the channel. So today we are going to talk about another interesting problem statement on the DSA, data structure and algorithm. So what we are going to do is we'll first understand what this problem statement is all about, and we will first try to get a working solution. Okay, we'll understand what is the time and space complexity for this, and then we'll see can we optimize this solution. Okay, and we'll see an optimized solution. Okay, so this is what we are going to talk about in this video. So this is a kind of a medium type problem that will be asked in most of the companies, or similar kind of a problem statement in most of the companies when you face an interview, right? So let's first try to understand the problem statement. So what is the problem statement here? So this is again another problem statement from the Leetcode. So the problem statement is, let's say you are given an integer array, okay? An array name is height of length n. So it will have some n number of elements. And there are n vertical lines drawn such that two endpoints of the ith line are I0 and I height of I. So that means by using each of the element that is mentioned in the list, we have to draw the vertical line. Okay, then what next? Find two lines that together with the x-axis form a container. So we have to basically find two lines that are forming the container, okay, such that that container contains the most water. So we have to find a maximum container by using those available lines, okay, which can basically contains or hold the maximum water, okay, and we have to return that maximum amount of water a container can store. So we have to basically return that two elements, or that how much water that can be stored in that particular container. So some more details available here. So you can see, for example, the input array having this particular list of elements, or a height, you can say 1, 8. So this is x-axis, this is y-axis. So each bar you can consider that as a x-axis element like 0, 1, 2, 3, 4, 5, 6, 7, 8. So the first height is 1. Okay, that means you can see the first element is here, sorry, height is 1. Second is 8. So you can see this is the 8. Then 6, then 2, 5, 4, 8, 3, 7. So this is how your vertical lines will look like. Now we need to find a maximum, basically two lines which can form the maximum container. So here if you see, now we have multiple lines, but if you see, the second line and the last line, they can hold basically a maximum water. Why we say that? Because let's consider, if you consider the second and third line. So second line is 1, 2, 0, 1, 2, you can say. So this is a 2, and this is a maximum we can go till 6, because if you go above this, water will flow out, right? So 6. So length is basically, this length is 1. 1 into 6 will get only 6, right? If you take between this line and this line, okay, this one, so here again we can go till max 7, right? And the width is 1, 2, 3, 4, 5. So 5 into 7, 35. That's what we are getting, okay? But if you see first line and last line, so how much is width? 1, 2, 3, 4, 5, 6, 7. 7, and the height is 7. So 7 into 7, 49. Okay, so basically we are considering a square. The square area, how we calculate, is a length into breadth. Okay, so we are getting 79, 49. That's why we are saying, okay, this container will hold the maximum, right? So what is the response, or basically output will be having is a 49. That's what we have to get. Okay, so again, another example you can see here. So now we have to basically understand this problem statement, and we need to write a code for this. Okay, so let's first understand what it is. We'll try to understand on the whiteboard, and then we will try to write a code. So let's take this this array, okay, 1862. So let's say we have an array of height, HEIGST, okay, where we have and elements like 1862, 1862. Then we have 1862, 54837. 54837. Okay, so this is how your array is, and if you just draw it, Okay, you can consider, okay, one height is here, then let's say 8, something like this, then 6 is something like this, 2 is something like this, 5 is something like this, 4, then 8, then 3, okay, and then 7. Okay, so 1, 8, 6, 6, 2, 5, 4, 8, 3, and 7. Okay, so now we want to basically find the a maximum area. So that means we have to basically find. So this is something you can consider it as a width. Okay, and this is something you can consider it as a height. Okay, now why this maximum area we are calling it as a something like this? Okay, so this 8 is something we will just go a little bit up, and then I think I missed something. 1862548. 8 is there. Okay, 8 is there 2 times. Okay, and here 8 and 8. So yeah, 8 and 8. So here, if it is a 8, 8, we'll get a 64. And here, sorry, 8, 8, we have. So what is the difference? 1, 2, 3, 4, 5. So 8 into 4, sorry, 8 into 5, 40 is something that we are going to get it. Okay. So yeah, still we have to get this one. Okay. So this is the container we can consider something like this. Okay. Because height is 8 and width is 1, 2, 3, 4, 5, 6, 7. So 7 into 7, 49. That's what we are getting it. Okay. So now we have to do it programmatically. Okay. We have to do it programmatically. How? So we need to basically find, okay, find a length and width. Okay. So what we can do is, let's say we can use 2 for loop. Okay. Simply we can have a 2 for loop. P1 you can put it here. Okay. You can 2 for loop, or you can say 2 pointer. You can take P1 here, P2 here. Okay. And what we can do is, we have to basically, how width we can get it. So basically we can start it from here, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, that's how the total index you can use, and this is how we can use that as a width. And height is already given here, right? So what we can do is we can get P1 and P2 here, and first of all we can get the length. Okay, so length, how we can get it? So length is basically the element, okay, ith element. So that's a 1. Okay, so length is 1. So now there is no point in taking the 0th element, right? So we can start from the first element. So what we can do is, length is, sorry, it's a height and width, right? So let me just add the height here. So height is basically we have is 8, and width, how we can get it? P2 minus P1, we can get the width, that is 1. Okay, and area, how we calculate area? Area is equal to 8 into 1, that's a 8. 8 is the area. And initially we can have a max area as a 0. So now if it is, this is greater than that, then you can consider, okay, max area is 8. Okay, now let's take the next element. What is next? Next is we can move P2 here. Okay, we can remove the P2 from here and we can move P2 here. So now, what is the P2? 6. So what is the height? Height is 6. Width is 2 minus P2 minus P1. That's a 2. So 6 into 2, 12. So area is 12. So now our max area is 12. Okay. Then next, move your P2. Okay. Move your P2. P2 is now this one, 2. Okay. So height is 2. Your width is 3 minus 0. That's 3. So 3 into 2, 6. Okay. So you are now height is max is max is 12 only, right? Because 6 is not greater than, so 12, that will remain only that. Okay. So now let's go move your P2. P2 is this one. Okay. Sorry, P2 is the next element. That's 5. Okay. So again, I'm writing there only. So this is a P2. So now again, what will happen? Height is 5. Then 4 minus 0, that's a 4. And area is 20. Okay. So this way, we will keep doing it for each element. And then whichever is the max, we'll keep updating the max. Okay. Once first iteration is done, we'll take the P1 here. Okay. We'll move our P1 here. And again, we will move P2 from here. Okay. P2 will start from here again. Again, P2 will move forward like this. Okay. And we'll keep doing it continuously. Okay. And that's how we are going to get the max area. Okay. So let's do that first. Let's see if we are getting a correct output. And then once we get a working solution, we'll talk about that. What is the time and space complexity we are going to get it. And then we'll see how we can optimize it. Okay. So let's go back and write the code here. So writing code is very simple here. So what we can do, let's say area initially we consider max as a 0. And then we can use a 2 for loop. So how we can use it? For x in range. Okay. We have to get walk through till the length of the list. So which is length of height. And then next element to get it, we have to use another for loop for y in range, where again we'll go from length till the height length of the list. And what we need to do is, first thing is we need to get the length. Okay. So length is nothing but our element. Okay, which is y element, right? So how we can do that? It's the height of y. Okay, height of y. Then width, how we can get it? Okay, width. Okay, one more thing that we have to do is to get, we have to always consider, like let's say now we are comparing these two lines. Okay, the 1 vertical line and the 8 vertical line, right? So now if you form the container, what we have to do is we can form the container something like this only, right? So for example, if I go back, so if I go between these two, so I can form the container between something like this one. Okay, I cannot just find the container like this. If you do this, water will basically all water will go out of this container. So we can find this curve. So that means between these two vertical lines, we have to consider only the smaller minimum line or a smaller line. Then only we'll be able to properly calculate the area, right? So when writing the code here, what we need to do is to for a length, we can get the minimum between height of x and height of height of y. Okay, so whichever is minimum between this will give us the height. And then width, how we are going to get it? Width, we are going to get it basically between y minus x. Okay, that's the index. Okay, we are doing y minus x. So basically we are going for a second row. So second row is 1 minus 0, it's 1. Okay, and then how we are going to calculate the area? Area is equal to basically length into width. Okay, and then what we are going to do is, if our area, so this is basically a new area, and this is a max area, you can say. Okay, max area. So what you can do is, or let's name this as a area. So if max area is less than area, then what we are going to do is max area is equal to area. So we'll update our max area if it is less than the current area. Okay, and that's it. Once it will, now we are running it in a 2 different loops. So it will go ahead and just do it for all the elements, and at the end, after this for loop, we have to just return the max area. That's it. Okay, so now if you run it, first we can just simply run it and see if the basic test cases are getting passed. Okay, you can say both the test cases are getting passed. So that means whatever the logic we have used, it's correct. But if you submit it, okay, When we submit it, no, not necessary that we'll get a correct output, because when we submit it, our solution will be run against multiple different use cases. Okay, so at least let's submit and see what is the error we are getting. So if it's a very huge list, okay, we may get a timeout as well, because we are running between these two loops. Okay, so if you have 100 elements, so 100 into 100, okay, that much time our program will run. So you can see we are getting time limit exceeded. Why so? Because now you can say this is a very huge input list they have given, and if you run this like by using a tool, so it's going to take a lot of time. Okay, I just take an example of 100, but here if you see this array, it has maybe 1,000 element. So 1,000 into 1,000, or even it has more than that only. So if you do 1,000 into 1,000, that means it's a too much big, right? So if your loop is running that much time, so n into n, we are running two loops. So that's the n square. That's our time complexity. Okay. And if you see our space complexity, so space complexity, we are basically, none of this variable is going to grow as our loop grows, right? You can see here we have a static value, here we have a static value, static value, static value. So this is just a one. Okay, one is our space complexity. Okay, time complexity is our n square, because we have a two for loops, right? So how we can optimize? Definitely we are getting a solution here, but we should optimize it, because if you go ahead and just write this way, okay, definitely it's a working solution, but we have to, when we are working in an organization, when you are working on any problem statement, we have to make sure that our product performance is very good. Okay, if it is going into running into timeout, then that's not good thing, right? So now we will talk about how we can optimize this. Okay, so to see that, let's come back here. So basically, how to get the area? Okay, to get the area, what is the logic we have just used? Is the logic that we have used is, first we are getting a kind of a width. Okay, so how we sorry, we are getting a length or a height, you can say height. We are getting a basically the minimum of x comma y. Okay, x or x comma y. Okay, not x comma y, it's basically the actual element. Okay, so you can say actual element. How we are getting it? It's basically, you can say it as a actual array. Okay, height of x comma height of y. Okay, so that's minimum out of this. And then uh, into what we are doing is width. How we are getting? It's basically the y comma x. Okay, so y is our next element, or you can say p2 minus p1. P2 minus p1. Okay, let me just rough it and I'll write it again. So p2 minus p1. That's how we are getting it. Okay, so that's how we are getting the width, and we are getting an area, right? But what is happening is we are basically using two different loops. Okay, we are using two different loops to get the uh, all, means we are just looping through all the elements and then finding the max area. Okay, but is it really required to do that? Okay, is it really required to do that? Okay, so what we can do is, okay, to get this solution better, okay, let me just maybe take another array. So let's say we have a height as an array, and what I do is I'll just take like, okay, 7 2 5 6, okay, or maybe let's say 8 here. Okay, now how we can do it? Basically, let me just write it here. Okay, so 7, let's say this 2 is this much, 7 2, then let's say a 5, this is 5, then we have a 6 which is here, and then we have a 8 which is here. Okay, so now if you see, ideally this should be the max container. Okay, this should be the maximum, or even if you let's take a little bit middle of that only. What we can do is we can have 8 here. Okay, maybe we can have 8 here and 6 here. Okay, so if that is the case, what will happen? Let me just rough this. So after 5, I'm taking 8 as this one, and then 6 as this one. Okay. So now what will happen if we just draw between 7 and 6? So what will happen is height is 6, and here 1, 2, 3, 4. So 6 into 4, we'll get a 24. Otherwise, another way is 7 and here 3. It's going to get 23 only. So maximum we are going to get is this one, 6. Okay, something like this. So we'll get 1, 2, 3, 4. That's a width, and height is 6. So 6 into 4, that's we are going to get is 24. Okay. If you do it with a 7, so width is 1, 2, 3. So 7 into 3, 21 only you will get it. Okay, even though we have 8 here, it doesn't matter because due to this width, area is getting increased. Okay. So now, how we can basically optimize it? Okay. So let's say if you do something like this, your one pointer is starting here and another pointer starting here. Now, what is our calculation? How we are calculating the area? Area is basically we are kind of getting a minimum of a basically height of a. Okay, height of a. Okay, comma height of b. Okay, so that's minimum out of this and into b minus a. That's what we're doing. Okay, so let's go through this. Okay, now if we do something like this, first we'll take a pointer at the start and then another pointer at the end. So if you do minimum of this two, so what is the minimum between 7 and 6? It's a 6. So we get 6 into b minus a. Now b is 0, 1, 2, 3, 4. So b is 4. This is 0. 4 minus 0, that's a 4. So we are getting a 24 is the max area. Okay, so max is 24. Okay, let's say initially we calculate this. Now next, what we can do is out of this two, whichever is the minimum. So out of 7 and 6, whichever is minimum, we move that pointer. So 6 is the minimum, we can move this pointer here. So that's a B. B is moving here. So what we can do is we can move our just a second, yeah. Move our pointer, this pointer here, because that's a minimum. Okay. Now let's do it again. Now this time what will happen? A height of A, it's a 7 again. Sorry, minimum between A and B. So A is 7, B is 8. So minimum is 7 here. Out of that, minimum is 7. And what is the width? Width is 0, 1, 2, 3. So 3. So this we are getting 21. So is 21 greater than 24? No. So max will remain 24. So now between A and B element, which one is the lesser? A is the lesser. So in this case, now A will move forward. Okay, A will move forward. Now, once A is moved forward, now let's do it again. Now this time, minimum of 2 and 8. Who is the minimum? 2. So we get 2 into B minus A. So B minus A is B is 0, 1, 2, 3. 3 minus 1, so 2. So 2 into 2, 4. Again, 4 is not greater than 24. So we are not going to change that. So now which is the minimum? A is the minimum. So in that case, A will move forward. So A will be here. So now what will happen here? So again, the minimum between these two. Which one is the minimum? 5 and 8. 5 is the minimum. And then B minus A, B is 0, 1, 2, 3. 3 minus 2, 1. So 5 into 1, that's 5. 5 again is not greater than 24. That's it. So that's it. Now we don't need to check any further combination, right? Because we are not going to get any, right? Because we have covered all, right? So this is how we can optimize it. Now we are going through the loop only once. We are not going through multiple times, right? So let's try to write this logic. Now how we can do that? Now we are writing only one loop. Okay, we are writing only one loop. So what we need to do is we have to basically instead of a loop, what we can do is we can use some variables. First one is max area. then we can basically take a x. X is you can take it as a 0. Okay. Then y position we can take it as a length of height minus 1. So that's would be at the end. Then what next? We can just do while we are going to move x forward, y backward. So if while x is not equal to y, okay, we'll go ahead. Now, once we get this, now what we need to do is we need to calculate the length. How we are going to calculate the length? Menu of height of x, height of y. Okay, we got the length. Width, how we are going to get it? It's the same way, y minus x. Now area, how we are going to get it? Length into width, we'll get the area. And then what we need to check is, if max area less than area, we'll as a reassign. Apart from this, what we need to do is we need to move the x and y pointer. How we have to move? If x is less than y, sorry, not x, it's a height of x, basically element. Okay, so height of x is less than height of y. Okay, if that is the case, what we need to do is we have to move x by 1, x position. Otherwise, else what we need to do is move backward y. Okay, x minus 1, y minus 1. That's now we are moving the position and it will go ahead and do it for all. So that's how the logic we have written. So let's try to run it. So first of all, if I just try to run it, it should pass all the test condition. Yeah, you can see it's passing. So let's try to submit and see how much percent we are getting it better. Now we are running only one loop. So our time complexity is n only. Okay. So you can see it's a beating almost more than 84, almost 84%. Okay. This solution is better than 84% people. And even memory is also, you can see it's a beating almost 71%. Memory is, again, you can see we are not at all using any array or anything which is kind of growing it. Okay, we have only the static element. Okay, area is just using that same variable to just replace it. Length, width also doing this, x and y, area, all is doing that. So even our space complexity is just only 1, and time complexity is, we are running the one loop, so that's a n. So that's what we are getting the time complexity. Okay, so this is the basically a best optimized solution for this particular problem statement. Okay, so here basically writing a code is not much difficult. Okay, finding the right logic is very important. Understanding, like, okay, how we are going to calculate the length, width, okay, how we are going to calculate the area, okay, and then understanding the logic, okay, where like, okay, is it okay if I just move it once, and is it going to give me the maximum area? So understanding or behind the scene, that logic is very important to know, like, okay, whether how my area is going to be calculated, and whether the area will increase or decrease if I just test only XYZ combination, right? So that's very important. Okay, so I hope everyone understood this particular problem statement, and also the solution, different types of solution that we have seen. One is the first working solution, and then we have talked about the solution which is optimized. Okay, so if you have any query, please write it in a comment. So that's it for this video. Thanks everyone. We'll come back with another interesting video on the data structure. So thanks.